Imagine dying of thirst while standing on top of billions of gallons of water. It sounds impossible. On Mars, it's reality. Because Mars has water, confirmed, massive reserves, enough to fill lakes. But here's the part no one tells you. That water can kill you faster than the thirst. In the last episode, we solved oxygen. Survival rose to 10%. But oxygen alone, you last 3 minutes. Without water, 3 days. So now we face the next impossible challenge. Finding water that won't poison you. On Earth, water is everywhere. 70% of our planet. Rivers cutting through continents. Rain falling from the sky. You turn a tap, and it flows. Clean.
Safe.
Life-giving. So when NASA announced in 2015, we found water on Mars, the world celebrated. Headlines exploded. Mars could support life. Scientists talked about colonies, farms, futures. But here's what those headlines didn't say. Finding water on Mars and drinking water on Mars are two completely different things. And the difference can kill you. Let's start with the good news. Mars does have water. A lot of it. In 2018, using ground-penetrating radar, scientists discovered massive ice deposits, not just at the poles, not just in ancient riverbeds, but underground, beneath the mid-latitudes, buried ice sheets, stretching for miles. ESA confirmed it. NASA's Phoenix lander touched it. In some regions, ice sits just inches below the surface, enough water to sustain a human colony for decades. So the question isn't, is there water? The question is, can we use it? And that's where the problems begin, because this water isn't sitting in a clean reservoir. It's frozen solid, locked inside toxic soil, contaminated with chemicals that would destroy your organs in minutes. In 2008, NASA's Phoenix lander analyzed Martian soil and found something unexpected: perchlorates, toxic salts everywhere. On Earth, perchlorates are used in rocket fuel, fireworks, explosives. They're so toxic that even tiny traces in drinking water are regulated. On Mars, the soil contains 0.5 to 1% perchlorate by weight. That's not trace contamination. That's saturation. If you melted Martian ice and drank it without treatment, this is what would happen. Perchlorates attack your thyroid. They disrupt hormone production. They damage your metabolism. With continued exposure, organ failure, neurological damage, death. So yes, Mars has water, but it's laced with poison. On Earth, the challenge is finding water. On Mars, the challenge is purifying it. And this is where human ingenuity enters. Because NASA didn't just identify the problem, they designed solutions. First, excavation and melting. Robots drill into the soil, extract ice-rich regolith, heat it gently, just enough to melt the ice, without boiling it away. In Mars, low pressure. Second, filtration. The melted water passes through activated carbon filters. Dust removed, particles removed, organic contaminants removed. But perchlorates, still there, which brings us to the critical step. Ion exchange treatment. Water flows through special resin beds. Perchlorate ions bind to the resin. They stick. Clean water flows out the other side. NASA tested this. ESA validated it. It works, but there's a cost. It's energy intensive, time consuming, equipment dependent. Every liter of drinking water requires planning, power, precision. On Earth, you turn a faucet. On Mars, every drop of water is engineering. You're not just drinking water, you're running a chemical processing plant to stay alive. And even then, you're not finished, because Mars is cold. The average surface temperature is minus 60 degrees Celsius. At the poles, minus 125. Any water you extract will freeze within minutes if left exposed. Storage tanks need heating. Pipelines need insulation. Recycling systems must run continuously. This is where survival becomes systems thinking again. You don't just get water. You extract it, melt it, purify it, store it, keep it liquid. recycle it. Every single day. That's why NASA, ESA, and SpaceX all agree on one thing. On Mars, you cannot afford to waste a single drop. Everything is recycled, not some water, all of it. On the International Space Station, astronauts already do this. They recycle moisture from the air, urine from waste systems, condensation from equipment. 93% of all water is recovered and reused. Yesterday's coffee is today's coffee. It sounds extreme, but on Mars, it's not optional. It's survival. Every shower, every meal, every breath you exhale, all of it is captured, filtered, and returned. Because the next supply ship from Earth is 7 months away. Here's the shift. Most people never make. Mars doesn't ask, "Do you have water?" It asks, "Can you become someone who treats every resource as irreplaceable?" On Earth, we waste, we let taps run, we take long showers, we assume abundance. On Mars, you become an engineer of scarcity. Every action deliberate, every system monitored, every drop sacred. This isn't just about survival. It's about transformation. You're not just finding water. You're becoming someone who understands. Life isn't given. It's engineered. So where are we now? With water extraction, purification, and recycling systems, human survival on Mars rises to 15%. Still fragile, still dependent on technology. But with oxygen and water, we're no longer surviving hours. We're surviving weeks. But there's something you still can't see, something invisible, something that's been damaging your cells since the moment you landed. Radiation. In the next episode, we face Mars' invisible killer, the radiation problem that turns every day on the surface into a countdown. Can we shield ourselves? Or is long-term survival on Mars biologically impossible? If this changed how you see Mars, subscribe, because surviving another planet isn't about finding answers. It's about asking the right questions, and every question we answer brings us one step closer to becoming Martian.